Coding practices. Coding practices are very important, uh, especially during the implementation of a software project. And if the coding practices help those who involved in the implementing the software to conduct the coding activities in a common way. So that is the main objective of promoting the coding practices. Before discussing about the coding practices, it is good that we understand what are the challenges that involved in the coding activities. First one, as we all know, the software development is usually in a teamwork. That means more than one person is involved in the development work, and there may be some other people who manage, supervise, and guide the software development work. So several members write the code in one project. At the same time, few members will supervise the development work. Software development is concurrent. What does it mean? Coding is a parallel activity. Always, these several people, they do the development work at the same time and from the different computers. So the different parts of the system is being developed at the same time. That is what we call concurrent. Modular wise code development. It, at the same, some people may develop one module, another group will develop another module. It may be an individual, it may be a several other people. So the whole development we can see at a time as the evolvement of the modular wise. Code-based management using a repository. In this context, it is very important to have a kind of a way to manage the code. So we call the code-based management, where we manage the whole code using a repository like a GitHub. I think you all have now learned about the GitHub. GitHub is a very important tool environment for the development of the software product. Independent verification. That's another challenge that we have it. Usually one team will be assigned to develop the software project, and another team is supposed to verify the development work, the software as well as their output in an independent way. And usually this team, we call it the QA team, quality assurance team, which verify the code independently, and they provide the detailed report to the development party as well as the management who uh, control the whole project work. Traceability when coding. What do you mean by the traceability? Identifying the particular code segment with respect to the relevant requirement as well as the design part of it. That may be in a kind of a traceability. Therefore, we usually call there are two types of the traceability. One called forward traceability, other one is we call backward traceability. That means from a particular requirement, we should be able to identify the relevant code segments in the code base. Or looking at by looking at a particular module class, we should be able to identify the relevant design or the requirement. So both mapping are very important. This is can be considered as a mapping between the design and implementation. Independent maintenance is another big challenge that we get usually in a uh, software development project. The maintenance means that after the development, what we call implementation, the software will be deployed. But once the software is being used by the other people, there may be many requests to modify the code, correct some bugs and the errors, and those activities comes under the maintenance. We will discuss the more details about the maintenance activities. But important thing, the maintenance becomes an easier or difficult task, and it depends on the how the coding has been carried out. If bad practices are used during the coding, then obviously maintenance will be more difficult. So and at the same time, it is not the same group of people who are maintaining and developing the software product, and usually a separate team will be appointed at a later time to maintain the project, and therefore there will be a big challenge, and there is a responsibility. And on the other hand, the development team, those who are implementing the software product, to carry out the work in a way that will help the other people to understand the software uh, project or the coding very easily.
When we talked about the coding practices, uh, it is very important, as I mentioned earlier, the code should be written in a way where others can understand. We call it this is a predictable and maintainable. So uh, for to do that one, the people need to follow the common standard, where everybody will write the code in the way that they practice, but using the common standard. So we will discuss what are these common standard, common conventions that people need to follow when writing codes. Uh, it's also very important to keep in mind uh, the code is written by one person or one group, and it will be maintained by another group. And rarely the same people will do the maintenance in a large scale project. We use the term called the clean code or good code, usually clean code. If the code is written in a way where others can modify the code for different requirements. What are these requirements? Sometimes people may realize some sort of errors, and therefore correcting errors will become easier. And there may be a requirement to add new functions or uh, extend the features of the current functionality. This modification become easier if the code is written in a way where others can understand. At the same time, uh, if a particular piece of a software is running, it doesn't uh, give a guarantee that the code is written in a more understandable way. So, running software indicates kind of a different. It is a different indicator, but the clean code of the running software is another indicator. There are main areas or objectives that we need to consider when coding practices are discussed. The first one is the reliability. I hope that you may remember reliability is a kind of a quality feature of a software, and it indicates whether the software is fault free, whether it works with any problem. So there are two ways this reliability can be improved during the coding. First one we call fault avoidance. So that means develop the, the software or coding that the errors are not introduced. So it's a very important, the practices should help the people to minimize or avoid the errors that people could make it during the coding activity. Fault tolerance. It means they develop the software uh, in a way that the program continues even when the faults occur. So it has in a kind of in a way uh, to continue uh, without making the big problem to the users even in that context. Therefore, these are the two uh, objectives that comes under the reliability. Readability is also a software quality that can be described not just the way the people can read and understand. If another person can modify a particular piece of particular a segment of a code to correct errors or even to expand its functionality, that is the what we expect the second objective of the coding practice. Reuse, we will discuss more about the software reused in the next few slides, but it means that the code will be able to use in the other modules or maybe other software development projects. So that highly depends on the practices people follow, because the reuse will be done by another party, and if they are confident, if they feel this code is developed in a good way and it has a clean code, then that promotes people to reuse it in other projects. Okay, let's discuss some details about what are the practices for program for reliability. As we said, the fault avoidance. The main objective is to ensure the code has few errors as possible. How can we do this one? So there are different practices. You can search and find out what are these practices. Just let me give you a few examples. If the code is using some meaningful names, where someone else can easily understand the purpose. The variable name should be meaningful for the purpose of using that particular variable. That can be considered as a good practice, and those misunderstandings may not occur when the uh, other people go through the code. Modularization could be also considered as a kind of a fault avoidance technique, where the large set of a code could be divided into two parts, and then smaller segment of a code in a particular module will help the people to understand its main objective, will not confuse the problems. So like that, there are so many practices that you can identify under the fault tolerance, and I suggest you to search on the internet to see what are these practices. Then the other one is a fault tolerance, where we aims to produce the code that will continue to function in the presence of errors. So that means some errors could occur, but the code will work. So which is a requirement, and even due to unexpected problems occurred, still uh, the code will not create a kind of a problem. How this can be done? So there are several practices. For example, one called the exception handling and defensive programming, fault recovery. Let's discuss them in detail, but these are not the only practices to minimize the fault tolerance in a particular code base. There are other uh, practices. So let's discuss these things very briefly. Okay, exception handling. What is this exceptional handling? It's a kind of a feature that comes in the programming languages, and some programming languages support the exception handling and some others are not. For example, languages like Pascal, C, they don't provide the exception handling facility in those programs. But Java is a very popular programming language which directly support the exceptional handling. What do you mean by this exceptional handling? Suppose that there is a procedure that calls another procedure. If let's say it's a first procedure as in a procedure A, second one as a procedure B, and when the procedure B executes, assume that will call another procedure called procedure C. So then there are three levels in this program, and something may goes wrong. That is what we call exception. Okay, occurs while the code in the procedure C is being executed. So then what will happen? The program should not come to an end, or should not happen something bad. It should communicate this what's gone wrong to uh, the, the higher level procedure. That may be the procedure B, from C to B, then from B to A. So another decision can be taken uh, to avoid such a situation. So this communication we call signal to the upper level to take the corrective action. Let's see how the exception handling is done in Java programming language. So assume there is a class called uh, uh, class counter, and where we'll do the simple average of a given number of values, and we can first get the total and then divide by the number of values. But there may be in a situation where the total number of values are zeros, then we cannot divide that total by 0, because we should have at least one number to divide it. So the exception will be when the total number of uh, available is 0, exception is thrown. So we give a name for that exception called the divide exception. And if that is not the case, then we can write the code to how to calculate the divide. And suppose then we have another class called my class, which is a higher level class, and it call the class counter, and there may be some method, and we defined a variable called counter1, and which has the type class counter, and we may write some different codes to implement it and get the average. However, due to some reason, if the total number of numbers are 0, then it will definitely throw an exception. But just throw an exception is not enough. In this higher level class, we should be able to catch that exception. So we use a statement called try and catch. Within the try and catch block, the catch, and we put in a divide exception. You can see the divide exception is the type of the name, and we use this E. It is actually the variable, and where we will get this exception into the E. Okay, and here the system output print the the division by 0. So this is the simplest way how the exceptions are included in a particular code base. Therefore, the program will not get into a kind of an unexpected situation due to uh, exceptional things that could have occurred during the execution of a particular piece of software. Program for readability, the second one. The major problem in the reviewing and maintaining code is sometimes the code is unreadable. That means the others can't understand it. If they can't understand, they can't modify it, and also they can't add some modification or correct it. Even the correcting errors become not possible when code is unreadable. Uh, Several practices are available uh, to improve the code readability. And here are three practices, one called the naming conventions, data types, and the control constructs. But there are so many other practices. I suggest that go through search on the internet to identify what are these practices, and use the discussion forum to discuss the coding practices which improves the readability. Naming convention. Let's see some details about it. It is a very important thing when more than one person involved in the software development project. As I explained, the development may be carried out by one person or one group of people, and the maintenance will be carried out by another group of people. At the same time, the quality assurance team will also go through the code. They also need to understand the code. Therefore, having a good naming convention within when different people carried out the coding is a very important requirement. So what do you mean by the naming convention? The kind of in a way whenever the programmers defines the variable name uh, and starting from the program name or function or procedure names and the constant names, the source file names, any one of them, not only the variables names, a kind of a common format. The people need to follow this format when they identify the or when they write the uh, during the coding, when they during the coding. This is an important in reducing the effort required for anyone except the author to read and understand the code. So that will uh, uh, provide them the support uh, and understanding, and also people know the purpose without checking the documentation. Just putting in a comment statement describing that uh, what is the purpose of this name is not required. Uh, the others should be able to quickly get the idea, okay, this variable is declared, this procedure is declared for this purpose, and they will have some sort of an easy way to follow it. Because in some people think just describing everything in the comment statement will help. Of course, that's not the case. Okay, the naming convention. Let's see how the naming convention help. uh, and especially the code reviews and the maintenance. What do you mean by the code reviews? Code review is usually carried out by a senior person in the organization or in the team, and they check whether code has developed according to the standard of the organization, whether the people have some responsibility when coding the software, so it is not waiting for the last time when bugs comes out. It's a kind of a regular activity in organization. So objective here is to the person who is not familiar should be able to understand, okay, this is the purpose and the things are done in a proper way, and definitely that will help to change the code according to the future requirements. So it is a very important to have a standards at the organization level, allowing people to follow these standards when coding is carried out, especially uh, naming conventions and the other requirement. So meaningful names according to the naming convention is the standard practice, and as I mentioned, the name of a function should reflect the purpose of the function. So that is so they don't say all the this way. It's a kind of a high level guideline how to give a name, and probably kind of things like how the first letter should be and how long its length should be, and whether the people can use more than one word. Those things could be included in uh, the the standard document for the naming convention and the other things. Let's see some examples of naming conventions in a C program. Uh, a constant, as you know, the constant is a kind of a placeholder in a program where its value will not change. And we can use naming conventions uh, like this. C, speed of light. So all the things are in capital. So that indicates this particular uh, name is given for a constant. All variables are mixed case with each word beginning with a capital, and variable names may be prefixed with a lowercase letter indicating the type of variable, I for int, L for long. Now see this example here, integer type variable called I current time. I is simple, that means anytime you see this variable, you know this data type is an integer. And the two words current time, and probably the purpose is described. We use the two words and the people find it easy without a space, because you can't keep in a space, and if you use these capital letters in this way, it's easy for readability. All variable names should be reflect the use of a variable, that it should describe the real world object represented. Here is an example: unknown word list. So it's three words uh, variable which has a data type list, so anybody can easily understand. It's a good and then if you just say the same thing under the u underscore list, it will be very confusing. However, you don't want to have such a descriptive things for indexes in a program like in a where for loop and the other loops, just to control it. You can use a simple variable like an ing for that thing. So some of few things, function and the procedure names are in a mixed case, with each word beginning with a capital. Function names may be prefixed with a lowercase letter indicating the return type of the function. So as I mentioned earlier, so V stands for the void and the V calculate total. So it means the people know when you call these functions, nothing will return, and its purpose is the calculate total. Function or procedure names must describe the purpose of the function or procedures, as I explained to you. And also people can use the similar convention when they are naming the file names. For example, this whole procedure can be stored in a file called the calculate total.c and contains the function calculate total. And even without looking at the content of the file, people will get the idea when they see this file name. Okay, the data types also will be could be used when we specially declare the data types in a program understandable way. For example, abstract data types could be declared in a way where the others can easily understand. See this example: traffic light color. So we define this data type which has a three possible value: red, amber, green. And then we have a two variables, color showing next color, and they are belong to the data type traffic light. So these variables can have only one of these values, the red, amber and green, and that will help the people easy to understand and use it, and also minimize the errors that could happen in a particular program, because it's not possible to assign another color to this traffic light color variables, because they are have only specified to these three things. Okay, let's see the other important practice, the reuse. So reuse means using something what you have it for in other projects or in the same project. And this is a kind of a practice that was introduced late 1990s, because uh, it was from 60s to 90s, most of the software was developed from the scratch. People didn't promote the reuse, and people have in the programming where they use the procedures within the program, the same code, repetition of the same code was avoided using the procedures and the function. So it could be considered as a type of a very primitive reuse within a program, but we are discussing here the reuse across the program. So reusing a particular module in a code base or class or procedure in another code base. So the significant reuse of the software was the reuse of the function and objects in the programming language libraries. So that's what we see at the early stage, but now the reuse has a new dimension. Okay, some more details. The cost and time schedule affects the negatively development of the reusable software. Software developed for current projects should be further improved for reusability. What does it mean? When people develop software for a particular purpose, they consider only that purpose. But if they have to develop the software for future reuse, which helps the others to use the software, they may have to put an additional effort. So the code base should be properly described. There should be a good interface for it, and other people could easily understand its purpose and understand the code, and this will take more time. This will have an additional effect. So the developing the reusable software uh, means has an additional cost which is not directly related to the cost of the current project. So it's a good feature anyway, which need to be promoted. And now there is it has become a popular methodology in the software development too. So reuse levels could be identified at the different levels. For example, the abstraction level, it does don't reuse the software directly, but use the knowledge of the successful abstraction in the design of your software. So, for example, the design patterns. I think I will explain more about the design pattern. It's a kind of technique people can use to improve their current design or find the better design for the problem they will have during the design stage. Object level, on the other hand, the directly reuse the objects from the library rather than writing the code yourself. So the referring to a particular library and use that the library. So people don't want to write; they can simply call the procedures or the functions from that library. The component level. Components are collection of objects and the object classes that you reuse in the application systems. So it's the kind of mechanism. So rather than you take the whole component, so you don't want to code develop that component, you can directly call that one. So the uh, sometimes it's a very good that if people can develop the software considering these kind of different stages, which will help the people to take the one component directly in another one. So there should be some sort of an independence between the component. We call this in the software engineering low coupling. Okay, low coupling within the components. The system level. So the whole system could be reused. Maybe the whole system could be in a submodule in another system. That could also happen. So it's not the replacing another system. So one system could be in another system. So in these days, people are talking about a system of systems. So that means the several systems can be combined to create a new system. To do that one, people need to have a good interface among these systems. We usually call this uh, good interface as an API, application programmers interface of the system, which facilitate other systems to use the particular system. So if you put these four things, four main things as in the four dimensions in the software reuse practices, where the whole system is used in another thing that's called the COTS, and the other one is what we call the component level reuse. So it may be a framework. Sometimes you will learn about these things in the future more details. Architectural or and the design patterns. So abstraction level, where the when people develop the software, people can use an architectural pattern to improve their design or to find the solution, where they rather than trying to develop everything from the scratch, that will help the people. So it's an important. And then the programming language, that is the library level, where the objects they can refer directly. So those things could be considered as the four dimensions of the software reuse. As I mentioned, reuse always has a cost of the development, but also on the other hand, if somebody is planning to reuse a particular piece of software, that also have another cost. Cost of the time spent in looking for a software to reuse and assessing whether or not it meets your needs. So it's like in a shopping to identify the good software. And just identification involves some detailed checking that also where people will have to spend time. So it's a reuse is whether it is in a it may not be sometimes free, but it costs even if they follow that mechanism. Where applicable, the cost of the buying the reusable software for the large off-the-shelf systems, these costs can be very high. Already is in a big market, a developed software for reusability, and there is in the marketplaces where people can sell the reusable software and other people can buy. In the Java world, Java Beans is in a very popular marketplace for people to sell and buy reusable software components. So if you get a chance one day to learn about the Java programming, if you already know, search and find out about the Java Beans, and you can use the discussion forum to talk about the Java Beans. The cost of adapting and configuring the reusable software components or systems to reflect the requirements of the system that you are developing. So it's involved the time. I mean, if you take the reusable software, you can't straight away use it. You may have to do some modification. You have to configure, we call it. By configuring, you have to fix it. So it's configuring involves the connecting with an existing sort of software, and that's you need to have some sort of a confidence. If you are not confident about this component, that will also have some problem. Cost of integrating reusable software element with each other if you are using software from the different sources and with the new code that you have developed. So integrating, so combining reusable software elements with each other. So that will involve a kind of a serious activity. So probably when you practice these things, you will understand more and more details. So the promoting the reuse of the software is now sometimes termed as the reuse-oriented software engineering. So develop the software and use the software. So there is a challenge, as I mentioned, integration and the configuration of these components, modules, and the systems in the software engineering practices. So we can visualize this whole process within several stages, where if you hope you remember the requirement analysis as well as the process development, where first thing will be to identify the requirement of the software we wanted to develop. So we put that one is what is called the requirement specification. So based on the requirement specification, people will do the shopping. That is what we call the discovery. So identify the suitable software that or components that will meet the requirement. And also they will have to evaluate. Just identification is not enough to test whether this is really matching the requirement, whether the purpose is exactly what we want. So these two things will have to carry it out. And then if they decided to reuse a particular component, it has some influence to the original specification. So we call this one as a requirement refinement. As you can see, the fourth component, requirement refines, it has an effect. So based on the selected component, it will have something. So let's discuss these each stages in detail, where the requirement specification, as you know, initial requirements of the systems are proposed in this document, and they do not have to elaborate it in detail, but should include a brief description of the essential requirements and the desirable system features. So the one advantage, you don't want to go to the details in a high level. A description of the specifications sometimes would be enough, because the main reason, as I said, the refinement will come. Then comes the other two stages, where software, the discovery and evaluation goes together. Given an outline of the software requirement, the search is made for the component and system provide the functionality required. So the shopping part. The other one is the checking part. Candidate components and the systems are evaluated to see if they meet the essential requirements and if they are generally suitable for use in the system. And then comes the fourth one, the requirement refinements, where refinement of the requirements. So during this stage, the requirements are refined using the information about the reusable components and the application that have been discovered. Okay, so will have an effect, and people may modify it, because if they decided to go within a selected component. Requirements are modified to reflect the available components, and the system specification is redefined. Where the modifications are impossible, the component analysis activity may be re-entered to search for alternative solutions. So that is also could happen if people see it is not possible to change this original specification without making a kind of a significant change into the original specification. They will have to give up the idea of using that particular software model and look for something else. That may happen if the refinement cannot be done without having a significant issue of the initial specification. Look for something else. And then the other one is the application system configuration. What do you mean by this? If off-the-shelf application system that meets the requirements is available, it may be configured for use to create the new system. So it's there, some settings should be modified to suit for the specific requirements. So probably this reusable component or the system may have developer as a to use in any system. So the configuration will have to some form of customization for a identified requirement. Then comes the other thing, the exercise the people will have to do is the component adaptation and integration. So which is a very, very challenging sometimes. At this stage, if they find it a big issue with respect to the adaptation and integration, they will have to go back and they may have to give up. And that may also will happen. So, so these are two alternatives. One configuring an application is the one, and the other one the components available. If there is a no off-the-shelf system, the individual reusable components may be modified and the new components are developed. These are the integrated to create the system. Most of the time, what we see in the system development is something like, so there will be components developed by the team as well as the component adapted from the other system. So it is like in a family which has their own children as well as the adopted children. So both will have to live as in a one team, in a one family. So it's in a very interesting, and the people should be have a good mindset to do it. So most of the time, people don't have a good confidence when they adopt some components developed by the other people. So it's like in a you treat your children as well as an adopted children together in the same family. Yeah, so big challenge. Okay, then let's discuss some other aspects in the reusability. How do we select the programming language for a particular project? And this is a challenging decision, challenge for the people at the very beginning. Which programming language are we going to use? Can we use more than one programming language? Are we specific to one language? So traditional approach where you develop everything using in the one language. But the modern environment facilitate people to develop different components using the different programming languages. So, for example, the framework like a .NET facilitate to develop different models. But there will be lots of issues. So when different family members speak different languages, that will not be easy to communicate within the family. So like that, uh, those challenges will be there. So the technical consideration for the programming language, the first thing would be the environment, the target environment where the software will be run. So the direct support for the programming language to the operating system is something that you need to check. For example, if the software is developed using the Visual C++, they usually have the compilers where they can produce the software which can run only the Windows environment. So based on the operating environment, people will have to think about whether which language support. But at the same time, there are languages which I described on the other thing, like the Java, where virtual machine concepts help the development team to run the same piece of software on a multiple platform, multiple operating environment. So where they do not want to think very seriously about the host operating environment. They may code considering the one thing. So there is an interesting statement or motto where once code run anywhere. So the language support, it's also very important, especially whether there are some libraries and other things available that will help the developers to easily and faster development of the software. Otherwise, people will have to code everything from the scratch. And if they have access to the libraries, things will be faster, definitely. So some more technical consideration, the performance. What do you mean by? It's the speed of running the program in a particular environment, So it depends on the several factors. For example, if the compiler and the interpreter are two different things, if the program language is based on a particular the uh, interpreter, it will be slow. Usually the programs written using the visual basic or the basic programming language is slow. Uh, Java and things which are running on a virtual machine are also considered to be slower than the target environment. But there are some techniques where people can speed up the performance. For example, in Java, there is something called the JIT compiler, where people can enhance the particular version for a particular given target environment to increase the performance. Safety and security is also another two important critical factors people need to consider when they are selecting the programming language. Uh, for example, some languages have provided a more safety and security control, like in ADA is considered to be more on the safety and security side than the traditional C. Interfaces to the other systems. If the application must interface to other systems, then these may restrict the language which can be used. Uh, so why? What is this one? If the application must interface to the other systems, uh, it's a very important. I mean, this is having a good interface. We call without people do not want to go inside and see how things work. They can just use the service which is declared in the interface. So API, as I mentioned earlier, application programmers interface is something people develop, and the support from the system will help that one uh, during the coding. So when selecting a programming language, we also have to consider the non-technical aspects. Sometimes the non-technical aspects are more important than the technical aspects. For example, project goals, business objectives, capabilities of the people, and things like that. Time scale, selecting the programming language among the developers to develop the system on time. So if let's assume if the programming language is something new to the development team, so they will have to spend some more time to learn the language. If they are already familiar, if they have done the similar projects or done some other projects using the same programming language, things will be faster. So the timing factor is a critical thing. And they also have to think about the future team, and probably they don't know who will be the future team, but uh, the team, if the maintenance team also should be familiar with the programming language. So especially people are very serious when they are selecting the new programming language, because that will force definitely to train the maintenance team in advance in this environment. Something more, if we go for the other application, if all other applications built and maintained by the organization are written in a programming language like a COBOL, for example, then there is a very strong argument for building new application in COBOL. So this is what we call the cultural issue. So if one thing is in another language, so always if there is a foreigner works with us, and probably he may has his own language, different language, and getting with the others will always there will be a challenge. So that is the kind of a traditional thing, but today we have an environment and tools available to avoid it. Available tools. What are the compilers, debuggers are currently available in this that comes with the particular programming language. Buying in a new software to support the development may increase the development cost significantly. So, especially changing to the new environment, new tools, uh, because of the marketing, people may adapt, because of the new features, people may adapt, but obviously that will lead to some sort of additional cost, and also will take more time. Okay, a few more non-technical consideration. The risk. What do you mean by the risk? There are two sides of the risk. I mean, the something that could be happen in the future. Not sure 100% it will be happen. If it is happen, it will have a very negative effect on the development of the software. The whole project will have a big problem. And that non-technical consideration, usually people need to think about the possible risks that could happen in a project, and also should have some sort of a plan to avoid that risk. This is known as the mitigation plan. So a risk analysis is an important practice that people should do it at the very beginning. So adopting the new technology, for example, always carries an associated risk. On a project which is critical to the business risk may be unacceptable. So sometimes there may be bugs in the programming language compiler, or there may be a uncompatibility of the programming language and the target environment, especially when people have to do something new. Always have an associated risk on that one. That has to be analyzed and should be studied at very beginning of the project. Morale is that usually the programmers love to use the latest technology, and because that will help the people to learn the new things and also apply them in the development. So it's a good practice to promote this kind of a thing in a non-critical project at an initial stage, and also identify innovative approach to develop to retain the interest of the staff. So we'll help the people not doing the client-based project. Start with an in-house software development activities. Usually happens in the many organization, and interns play a bigger role in that case, as far as I know the industry. So industrial placement is something that most of you will get a chance to go in your third year of study. Uh, so that is another non-technical consideration. So the final advice on how to do the good programming, and before you do start the writing the code, you will have to do a few things. First thing is to make sure that you understand the problem. So you can't code if you don't know the problem. Okay, just looking at the document, it is not possible. The whole understanding is very important. The basic design principles and the concepts. If the people have no idea about the design pattern that has been proposed in the design level and some of the architectural consideration, the people may code thinking something, but the actual requirement may be completely different. The design objective will be different and the code will be different. So then that will lead to a kind of a bigger problem in a software development project. And the pick a programming language that meets the needs of the software to be built and the environment in which it will operate. Okay, so that analysis should be done. Where this will be deployed, how it will be deployed, how people will be used. So that the deployment requirement, how these things will be maintained, must be think about before selecting. So select a programming environment that provides tools that will make your work easier. Okay, so it depends on the time of the kind of an environment where the good support is available, then much more easier. I know that some people prefer to go for an environment like a .NET because it comes with so many tools and so many support, but at the same time there are pluses and minuses in every selection. Create a set of a unit test that will be applied once the component you code is completed. I mean, very important advice. People should not let the sum of the codes to bypass the relevant testing. Every code that you write should be tested. So the unit test is the first level of testing. We will discuss in the next section details about the unit test, but make sure every code that is in the program should be tested. That's the one thing. And there is another thing where people always say bad smell of the coding. So if it is not a clean code, if it is a code is bad, people usually use the term bad smell. So the bad smell gives the bad feeling for the people. So that is kind of the feeling people will get it in the coding environment. So avoid the bad smell. There are lots of practices, there are lots of guideline design patterns, and where people will help to correct those mistakes, and we will discuss in the future something very important practice called the refactoring. So the refactoring, as I explained on the other day, is a kind of a practice where people change the code without changing the external behavior, change the organization of the code base to make it more readable, reliable, and at the same time that will help people to reuse, modify, and maintain the code easier and faster. So more to learn, and this is the starting point.